How do I graph a rational function? Well, it's that same F word that we love to say, factor. So you factor. Factor the numerator, factor the denominator. Let's say that the numerator is like x plus 2 squared over x minus 3. I said over, I didn't mean to. X plus 2 squared times x minus 3 times x minus 1. And let's say the denominator is like x minus 1 times x plus 4 squared. I don't know, whatever, why not? Let's call that our equation. No, lies. Let's make this different. Let's add a factor of x minus 2. Yeah. And let's put a power of 5 in the top. Alright, so factor the top, factor the bottom. Probably going to have to do some factoring by grouping, some quadratic factoring, some difference of square factoring. So first step, factor. Once you have factored, we want to look for holes, aka removable discontinuities. So to do that, identify common factors in the top and bottom. And I found one, x minus 1. That means I will have a hole at x equals 1. Now, funny story, this equation will be exactly the same as 5 times x plus 2 squared times x minus 3 times, oops, leave it there, that over x plus 4 squared times x minus 2. It will be the same with the hole removed, except it will not exist at the x value of 1, because we have a hole there. But we can use this equation to figure out what was the y value of the hole. And we can figure that out by now plugging in x equals 1 to this simplified red equation. So what is the y value of that hole? The y value of that hole is going to be whatever we get. So 5 times 1 plus 2 squared times 1 minus 3 over 1 plus 4 squared times 1 minus 2. And you can simplify that. 1 plus 2 is 3, squared is 9. So I have 5 times 9 times 1 minus 3 is negative 2. Over 1 plus 4 is 5, squared is 25, times 1 minus 2 is negative 1. So boom, look, those negatives cancel out. And we are left with gross, disgusting nastiness. 5 times 9 is 45 times 2 is 90 over 25, which simplifies down because both of those are divisible by 5, and we get 18 over 5. And why did we just do all that annoying stuff? Oh yeah, that's because we want to be a little more precise because we're able to. The hole is not at just at x equals 1, it is at the point 1 comma 18 fifths. Sweet. That was a lot of work to do for that, but we did it because we are scholars. All right, what next? So we have found the holes, we have removed them. Let's find vertical asymptotes. I will have a vertical asymptote at x equals negative 4 because of that factor right there, and at x equals positive 2 because of that factor right there. Notice that x plus 4 is squared. The multiplicity of that vertical asymptote is 2, which means my tails will be together, either both down or both up. Versus my x minus 2 is a linear factor, so my tails will be going in opposite directions, either down up or up down. That will make more sense in a bit. What else? Zeros! Let's find our zeros, aka our x-intercepts. What? X-intercepts will occur at x equals negative 2. That will bounce because of the multiplicity. X equals 3, and that will cross. Okay, what else? How about a horizontal asymptote? Well, since the degree of the numerator is the same as the degree of the denominator, it will have a horizontal asymptote at the value of our coefficient, which is 5. So horizontal asymptote at y equals 5. If the degree of the denominator was greater than the degree of the numerator, then we would have a horizontal asymptote at y equals 0. If the degree of the numerator were greater than the degree of the denominator, we would have crazy things happening. Maybe a slant asymptote, maybe up, maybe down, crazy, nasty grossness. I keep describing all these problems as gross, but they're really not. They're super awesome. So we have all this stuff, and we can now piece things together. Let's get rid of all of that work, and let's do what we do. So, axes, schmaxes. I know that I will have vertical asymptotes at 1, 2, so I will dash that in, and 1, 2, 3, 4, so I will dash that in. What else do I know? I know I have a 0 at -2, so I can mark that, and a 0 at +3, so I will mark that. Maybe we should find our y-intercept. Well, our y-intercept is going to occur at 5 times 2 squared times -3 over 4 squared times -2. Where did I get those numbers from? I plugged in 0 for my x's. And again, I get like a really big, scary number. My negatives cancel. And we're left with what? 2 squared is 4, times 5 is 20, times 3 is 60, over 4 squared is 16, times 2 is 32, which will simplify to what? 30 over 16, which is still gross, and so we'll simplify it to 15 over 8. So 15 eighths, which is positive, which is actually really helpful. I'm going to move this stuff out of the way. It's helpful to know it's positive because now I know that my y-intercept here is going to be a positive number. So think about what that means. That means, imagine as I go from that y-intercept to the right, towards that asymptote, I have no choice but to go up because I don't have any zeros in there, so I cannot cross the x-axis. That's pretty sweet to know. So then I have to continue here. At that 0, what do I do? When x is -2, do I cross or do I bounce? I bounce. So I hit that 0 and I bounce back up. Boom. To that asymptote right there. So I get that little lumpy looking thing. And then what happens on the left? Well, what asymptote gave me the vertical, what factor gave me the vertical asymptote at x equals 2? It was this one right there, which had a multiplicity of 1, which means that since my tail started up to the left, it has to now start down to the right. So I'll hit that and I'll cross, and I know I'm going to be leveling out at, boom, 1, 2, 3, 4, 5. I know my horizontal asymptote is at 5, so I know I'm going to level out to something right about there. Scoobity boobity. What about to the left of there? Well, do you see that since I have a horizontal asymptote at 5, I have to be up like that? Because if I were down and I was going to that horizontal asymptote, I'd have to cross at some point. And I don't have any zeros over there, so I have to be up. Furthermore, I have to be up because the multiplicity of that asymptote is even, so my tails have to be together. So I get something that looks kind of like that. That's a lot of stuff. So much stuff that I forgot that I have a hole at 1, 18 fifths. 18 fifths is a gross number, but it is a positive gross number. It is 3.6, so I am somewhere 1, 2, 3, somewhere like about there, I have a hole. So I'll show my hole like that. And now I got it.